Welcome to the 12th video of the physics lecture series for the National Science and Mathematics Olympiad. In this video, we will cover the ways we can use graphs to solve kinematics problems. First of all, why would we want to use graphs when we already know the equations? Equations describe the motion mathematically, and graphs show it visually. Sometimes it's easier to just read the solution of a graph than to calculate it. By reading slopes and areas on different graphs, we can find various quantities, such as the displacement, the distance, the velocity, and the acceleration. Let's start with the position-time graph. On the horizontal axis, or x-axis, we have the time. On the vertical axis, or y-axis, we have the position. Using this graph, you can find the displacement as the difference between the final and the initial positions. For example, on this graph you can see that the initial and the final positions are both 0. Hence, the displacement is 0. Next, we can find the distance as the sum of all of these different segments here. For example, during the first segment, the object traveled 10 meters in 2 seconds. And then in the next 2 seconds, it moved 5 meters backwards. After these 2 segments, the displacement would be 10 meters minus 5 meters equal 5 meters. But for the distance, we have to add them. So the distance will be 10 meters plus 5 meters equal 15 meters. Finally, we can get the velocity as the slope of the given segment. The slope can be calculated as the rise of the function divided by the run. So the change in position divided by the change in time. So for example, for this first segment, the rise is 10 meters and the run is 2 seconds. So the velocity is 10 meters over 2 seconds, which is 5 meters per second. The next graph is the speed-time graph. Here, the horizontal axis is again time, but the vertical axis is the speed. Note that the speed is always non-negative. If the object is moving, it is positive, and if the object is stationary, then it is 0. From a speed-time graph, you can get the distance by calculating the area under the curve. For example, here I can divide the curve into 3 parts. The area of this first triangle will be 2 times 6 divided by 2. Then the area of this rectangle will be 3 times 6. And finally, the area of this second triangle is 3 times 6 divided by 2. So in total, 6 plus 18 plus 9, which is equal to 33. So the total distance covered during this motion is 33 meters. The next graph is the velocity time graph. So now we have the velocity on the vertical axis. The velocity can be negative, which means that the object is moving in the opposite direction. In this kind of graph, by calculating the area under the curve, you can get the displacement instead of the distance. By drawing this line at 0 velocity, we can see the situation more clearly. We will have positive areas, such as the area of this first triangle. These mean a positive displacement. But we can also have negative areas, such as this part, which is under the line at 0. So these parts will mean negative displacement. Adding these, we will get the total displacement. From such a graph, you can also get the acceleration as the slope of the given segment of the graph. So, for example, in this first segment, the acceleration will be the rise over the run. So, minus 6 over 3, which is minus 2 meters per second squared. It makes sense that we get a negative acceleration because we can see that the velocity is decreasing. Finally, we have the acceleration time graphs. Here, the vertical axis is acceleration. In such a graph, the velocity difference can be calculated as the area under the graph. For example, in this first segment, the acceleration is 2 meters per second squared for 10 seconds, which is 2 times 10 meters per second, so 20 meters per second. So during this first segment, the velocity of the object increased by 20 meters per second. If we have a positive area, it means that the velocity increases. But if we have a negative area, then the velocity decreases, such as during this segment. This table gives a summary of how we can use the different graphs to get the various quantities that we need to solve kinematics questions. Study it for a bit and try to remember how we use the slope and the area under the curve. But the best way to remember this is to deeply understand that the slope is the ratio between the change in the two quantities, and the area under the curve is the product of the two quantities. Thank you for your attention and see you in the next video.